So the antiderivative of t e to the t squared is e to the t squared, because the derivative of e to the t squared is, well, it's 1/2 actually, 2t e to the t squared, right? Thus, the derivative of 1/2 e to the t squared is 1/2 of 2t e to the t squared, which is t e to the t squared. Completely understand that? Okay? Well, what you have here is a lot of problems of the same nature, but we want a method for discovering or for working out what this actually is. Okay? So I'm going to illustrate that method kind of quickly, and then we'll talk about it much more slowly. Okay, so first of all, your antiderivative of t e to the t squared is denoted this way, okay? And that's just a symbol for antiderivative of, but that means also the integral of. The integral is just an antiderivative, okay? Now, there are indefinite integrals and definite integrals, and once you understand how to find the indefinite integral, which is what we have here, it's really easy to find the definite integral, okay? And we'll talk about that, but let's talk about these. Well, let's talk about this first and not confuse the two, okay? So what we can say is, here's the way it's going to look. We have this antiderivative, okay? And we notice that if we let u equal t squared, then what is du dt?
It's the derivative of tu over the whole thing.
Well, the derivative of t squared with respect to t is what? 2t. You know that. Okay. But in this new situation, it's easy to forget what you know, right? But that's straightforward, okay? So du dt equals 2t. Okay, well, du equals 2t dt. And that's not really as valid as it might look, because these aren't algebraic quantities. But if you think about the meaning of the differential, that still works, okay? And you don't have to worry about that. You can treat it as algebraic quantities when you're doing this. But keep in mind that they really aren't algebraic quantities. It's really something a little different, okay? Okay, so du is 2t dt. If you look up here, we have a t dt in this expression, okay? So we want to know what t dt is. Well, if du equals 2t dt, what's t dt? treat it like an algebra equation, try to solve for t dt. Divide both sides by 2, you get t dt equals du over 2. Okay? Okay, well, now we can write this integral as this. Okay? So we've converted this integral in terms of t to this integral in terms of u. Okay? And in a rather fairly simple, after you've done a couple of these, it becomes pretty easy, okay, to go through this. Okay, so we have e to the u times du over 2. Now you know when you're taking derivatives, a 1/2, the derivative of 1/2 of something is just 1/2 the derivative of that thing, right? Okay? So if you're doing the derivative of 1/2 e to the t, it's 1/2 of the derivative of e to the t. Okay, that's a constant rule for taking derivatives. Okay? And clearly, since we're doing antiderivatives, and by what we understand about antiderivatives, if you think about it a little bit, the same thing's going to be true for antiderivatives. So we have an antiderivative here with essentially a 1/2 factor. So that 1/2 we just bring right out of the integral sign, okay? Now what's the integral of e to the u with respect to u? Well, that's just e to the u. Because the derivative of e to any variable with respect to that variable is just e to that variable. So, you know, the derivative of e to the x with respect to x would be e to the x. The derivative of e to the t with respect to t is e to the t. The derivative of e to the aardvark with respect to aardvark is e to the aardvark. Okay? And the derivative of e to the u with respect to u is e to the u. Okay? Now there's a little more to it, because we could also add an arbitrary constant number. The derivative of 1/2 e to the u plus c is 1/2 e to the u, because the derivative of a constant is 0. So this is an antiderivative of this, right? So adding a constant doesn't affect the fact that you've got an antiderivative. So there are infinitely many possible antiderivatives, any constant. Okay? Well, that's a process we want to kind of practice today. And the final step of that, of course, is what is u?
It's t squared.
Yeah, so okay. Now if we take the derivative of this, don't we get t e to the t squared? Now hopefully from last time you're clear on the chain rule and the application. And in looking at the homework you handed in on Tuesday, everybody must seem to be just fine with the chain rule and derivatives of exponentials. Okay? So you've both obviously seen it. You're both obviously doing it right. So I'm not too concerned about your ability to take the derivative of that. Okay? So you can easily verify that the derivative of this is this. Okay? Now let's practice that for a couple more examples. Okay?